there's this limitless universe of forms out there that is just surreal, otherworldly, sculptural, architectural, insanely, ridiculously beautiful.
We installed 5 cameras in total on that trip. After that, we went on to Greenland.
When glaciers break these gigantic icebergs off into the ocean, it's called calving, C-A-L-V-I-N-G. Ever since glaciers have entered the ocean, hundreds of thousands of years ago, ice has always calved off. But what we're seeing now is the Greenland ice sheet thinning out.
You know, Richard Avedon and Irving Penn had found endless variation and endless beauty and endless magic in those faces. And, you know, you feel they're crumbling into these tiny little blocks of ice going off into the ocean. It's crazy.
By looking at the chemistry of the ice, we can learn about past temperature, and by looking at the air, we can actually measure the carbon dioxide content. And one of the things that we learn is that past temperature and carbon dioxide vary together. They go up together, they go down together. And over the last 800,000 years or so, atmospheric carbon dioxide was never higher than about 280 parts per million, until we started adding carbon dioxide to the atmosphere. And now it's about 390 parts per million. And that's about 40% higher than it was when carbon dioxide was only varying for natural reasons. But now we're headed for 500 parts per million or more.
That pace is 100 to 1,000 times greater than the pace at which things have changed by themselves, naturally.
In 1984, the glacier was down there, 11 miles away. And today, it's back here, receded 11 miles. The glacier is retreating, but it's also thinning at the same time. It's like air being let out of a balloon. You can see what's called the trim line. It's the high water mark of the glacier in 1984. That vertical change is the height of the Empire State Building. Looking down on it. Now we turn on our time lapse. You can see the terminus retreating, you can see this river being formed, you can see it deflating. You go back a couple years in time, that's where it started. That's where it ended a few months ago. Now down, this is what we see. Look at this. You'll see deflation happening here as the heat takes away the surface of the glacier and the surface drops. At the same time, a stream is undercutting it from a glacier that's melting faster up valley, washing this thing away. The vast majority of glaciers in the world are retreating. Here's another time-lapse shot of Columbia. And everybody says, well, don't they advance in the wintertime? No, it was retreating through the winter because it's an unhealthy glacier. We realized it was retreating so far, we had to turn the camera upstream to follow the retreat. Then we had to pivot it again. And then, when we went back this past August, it was so far out of frame, we had to turn the camera one more time so we could still see the glacier. So that's where we started 3 years ago, way out on the left. That's where we were a few months ago, last time we were into Colombia.
The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around.
It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100. There's this limitless universe of forms out there that is just surreal, otherworldly, sculptural, architectural, insanely, ridiculously beautiful. And that's when I thought, okay, the story is in the ice, somehow.